An inside and outside look at all things NASA.
Hey, we're right here at NASA Langley Research Center with John Dorsey, who's going to talk to us about the LSMS. So what is this LSMS?
LSMS is a shorthand acronym for the Lunar Surface Manipulation System.
Okay.
So as part of NASA's exploration program returning to the moon, this time to actually establish more of a permanent presence at a fixed location, we need some different capabilities that what you would have had with Apollo.
Essentially, this is a crane. I mean, this LSMS.
Or as I like to call it, the Lunar Leatherman.
It's actually a cross between a crane and a manipulator. If you look at manipulators are usually able, they're very dexterous, have a large number of degrees of freedom, so they can pick up things, position them very accurately. Our device actually does both. 3 degrees of freedom right now in this device, a waist joint that allows the whole thing to rotate, a shoulder joint that allows articulation, and then an elbow joint that allows articulation. So by having 3 degrees of freedom, we can actually pick up payloads and position them fairly accurately. This is the first one that's ever been built, pretty much all off-the-shelf hardware in terms of the materials. It's aluminum extrusions, off-the-shelf motors, some specialized controllers and control systems.
And it's not like NASA, so this is to give an idea. Obviously, it'll look very different when we get to the final product.
This is a proof of concept to demonstrate operation.
Right. Okay.
The actual device, if we were to build it, take it to the lunar surface, would look very similar to what you see here.
Okay.
What we would do is we would have, for example, these are aluminum extrusions.
Okay.
And we can get a lot of benefit by switching to composites. So we get much lighter compression numbers. The motor that we have up on top of the king post is just an off-the-shelf motor, off-the-shelf hoist system.
Okay.
It'll be a very lightweight device when built using space-type hardware.
Now, how big is this crane? I mean, it's a big structure here.
The device that we're looking at, each of the links, we call the vertical member the king post, then we've got the arm link, and we got the forearm link.
Okay.
Each one is 3.75 meters long.
Gotcha.
It's actually designed to be a full-scale manipulator. So this is actually sized so that if it was sitting on the lunar surface, it's got the correct reach that it can reach up and take stuff off of a lander and lower it onto a mobility chassis.
Now, do you envision, when we get back to the moon, and let's say our lunar outpost is well underway, do you envision a number of these cranes, maybe different sizes and shapes?
We have a lot of versatility in this design, so given a particular payload, we can design a specific crane or manipulator to do that job. However, we're always thinking about, we can't take too many things to the lunar surface. We can't take a lot of weight.
That's right.
So ideally, if you knew before you went what most of the operations were, what the max payload was, what the max reach was, you could design one device, take care of all the operations.
Brilliant.
That's awesome. And if you maybe needed one extension for one big, piece of hardware that you were sending up, you could do that instead of building in a bunch of extra options.
Right. What we see here with a post and 2 links, we have versions, just for the heck of it, you can see a 1-link version here. This was when they wanted a specific design that would stay on the lander and just offload the lander, so we didn't need that extra arm.
Okay.
This one with the 2 links, arm and forearm, we've actually designed that so that it can self-offload from the lander. So when the first one lands on the lander, the first job it does is unload that lander. Then the tip of the manipulator can plug into a grapple fixture somewhere on the lander. The base releases, and then using the degrees of freedom in the device, the base can go down and attach itself to a mobility chassis like Athlete, plug itself in, release the tip. Now I've got a mobile manipulator, and that can now go around the base, unload subsequent landers when they come in. It's also designed that we can change the manipulators on the tip of the crane, so that you can put cameras out there, repair devices, inspection devices, so it can do a lot of different jobs.
As you mature this piece of hardware, Blair wants to be the first medianaut to go to the moon by the end of next decade. Right? So he's learning right now just how he's going to live on the lunar surface. So if you can build in some more simplicity so that he could actually operate it himself.
More simplicity is the key.
Yeah, that's the key for him, because if it's too technical for him, it's a lost cause up on the moon.
Well, within our Human Robotic Systems project, we are not only working the devices like manipulators and mobility chassis like Chariot and Athlete, but we're also building the, if you want to call it, the automation and control architecture that drives all the devices. So
take a look at that.
There you go. Yeah. So we'll have three levels of control.
That's great. I'll fit right in.
The simplest level is it's fully all automated. You tell it a task and push a button and it goes and does it. We would also have another level of control, which is more like teleoperation.
Right. So that means that there's somebody in another room with a remote control stick.
There's somebody at a remote station. It could be right next door. You know, for example, you could be sitting in the hab next door to this on the lunar surface with a control station, and you're saying, you know, slew left 50 degrees, you know, rotate arm up 30 degrees, etc. So you're driving it command by command, checking each operation, making sure it's okay before you go to the next one.
And that's true with all components. So like if you had Athlete and Chariot out there, all of those can be teleoperated as well. So
hey,
that's awesome.
First generation transformer.
Yeah, that's right. Now, we could just go from Buick to this.
That's right.
Then we're gold.
Sure.
It's great.
Hey, you're watching NASA Edge.
An inside and outside look at all things NASA.
Oh, that's pretty cool.
And if you do any remote testing here,
This is NASA Edge.